Thanks, everyone. Good morning. My name is Jessie. I am here from New York. I come from Cleveland originally. I'm really stoked to kick off day 2. I had a great day 1, so I hope you did as well. And I'm here to talk about enums. First, I have to clear something up. If I can advance my projector. There we go. So, despite the fact that I am almost certainly the newest, least experienced, most random speaker up here this week, I didn't mean to make that so obvious. I don't know. I didn't put anything in the company fields of the application. And when I saw this, it just made me laugh. Everyone else did because they're more illustrious and they might work at a cool company or have apps in the App Store or make incredible educational content. I don't do that, but I do love SwiftUI, and I have been working at it for the last few years. I spent the summer learning about Enums, so I'm excited to share that with you all. And I wanted to take this opportunity to just tell you a little bit more about who the heck I am and why I'm here. So I moved to New York to work in the Broadway community. I grew up in the theater. I love drums and percussion. I like musicals, and so I pursued that, and I've been doing that for about a decade. It's a really wild business, as you can probably imagine. Shows come and go, but it's really fun, and doing music for a living is awesome. That being said, there was a shutdown, 18 months, and it was really bad. Shows, I didn't know if shows were coming back. I didn't know if I'd have a job when they did. They did, and I do, which is good. But it was a really, really dark time, as it was for so many people across the planet. And I found about SwiftUI, and I learned what a string was. And it's like, okay, I downloaded Xcode after retiring my 2010 MacBook Pro, which got me through 10 and a half years. It was good, but couldn't handle Xcode. So, and I just fell in love with it. If you do SwiftUI, it's just really fun, and I'm like a puzzle girl, and I love languages, and to go up years and years without kind of scratching any of that, doing that in my brain was, it was a really refreshing thing to do. And because it was such a hard time, it gave me such a tremendous sense of personal accomplishment and a sense of dignity and joy that was just gone pretty much during that time. So I'm really grateful, and I'm really proud to be an indie developer. Yeah. And the community, you all know, amazing. People at the ready to help, share knowledge. It's been wonderful, and I'm just really honored to present here today. So as for the music side of things, just to give you an idea, I'm usually doing something like this. It's like fun. It changes all the time. In case you're not sure what's happening in the middle, I am lunging at a vibroslap. If you're not sure what a vibroslap sounds like, that's fine. We're going to write that wrong in a couple of minutes. Yes, really, we will do that. So that's fine. But yeah, my job sometimes involves vibroslaps, so that's lovely. That's me in a nutshell. So why enums? In Swift, enums are the best data type to represent a finite list of options that can be statically categorized rather than dynamically created by the user. And I love lists, and I love categorizing, so I loved enums right away. I did, though, also learn that depending on who you ask, enums are either underutilized or overused in Swift. And John Sundell's not the only person that I saw talking about that. So I'd like to take the temperature on this in the room this morning. Can I please get a show of hands? Who thinks enums are overused in Swift? Don't be shy. Oh, you're being polite. That's cool. Who thinks they're underused? Yeah, okay, that's a lot of hands. Is anyone undecided or hasn't used them yet? Oh, cool, okay. I don't even see hands, so everyone's used enums, and everyone pretty much thinks they're underused. It's gonna be fun. All right, so the more exposure I had to enums and I saw new ways people were using them, the more curious I became about what else they could do besides just, you throw some options in a picker, and they're great for that. But there's definitely more to be done. So I made this sample app called PocketPerc. The app comes preloaded with musical samples that can be mixed together. And I wrote a little 4-measure phrase, I created parts for a bunch of instruments, and then I left room for this little fill at the end, like a drum fill or like a vibroslap or something. And my goal for the project was to find out just how much I could use Enums, when I would hit the ceiling of their optimal capabilities, and why. So in essence, what would it look like to pretty objectively overuse Enums? And the app is small, so is 20 a lot? I don't know. I gave it my best shot. It may be, though. So the agenda for the talk is to do a little demo where I'll play you some of the samples so you can see what the app is. I'll show you some of the code and talk about some of the highlights and what I learned this summer working on it. And at the end, we'll make a SwiftLeeds 2023 mix together, which I'm really looking forward to. Also, the sample app and a slide deck are up on GitHub, so you'll be able to take a closer look at anything that interests you later on. Without further ado, a sample of my Sample Samples app. OK, so the home base of PocketPerc is the mix, and to add tracks, the user taps the plus button. Here, the user can quickly toggle tracks in and out of the mix, like so. And there are 5 categories you can swipe between in a little carousel. And I've been selecting 1 to 2 instruments per category just to get a coherent sounding mix and not just like all percussion or something. And it's been fun to use. Here, you can browse little clips of what's in the catalog. Here are a few of them. Here's all the fills. That's the viber slap. So, as promised. All right. So a user can pick multiple fills, or they can select this little surprise button and get a surprise fill at the end. I'm just adding a couple tracks, and this is where I would start mixing, but we're going to save that for the end. So that's the app. I want to review some basics for a couple minutes, and then I'll spotlight some of the topics that I've been working with. So consider this scenario: a list with a sort style for alphabetical or categorical. And here's one way to do this. It's perfectly workable, if not a little error-prone because of the repeated strings. But what we really have here is a category and a finite set of options. So that sounds like an enum. A core feature of enums is how they take version A to this, a more convenient and type-safe version B. We all know this because, we've all used them. And so, we get dot notation, we get autocomplete, and we love it. To upgrade an enum from an abstract representation of an object to an actual object, we can back it with a raw type, either a Swift type or a custom type, which I tried out for the first time with this project. I'm not sure I nailed it. It was cool to try, though. You can use a custom type. So if an enums cases have associated values, like this sort style case date added, the compiler will complain if you try to add the raw type. But it turns out you can write a manual conformance to raw representable, and that's what I did, and that worked really well. Speaking of associated values, they are so flexible. They can have a default value or not. They can have a parameter label or not. They can be of a Swift type, a generic type, or a custom type. They can even be an instance of the same enum via the indirect keyword, and that's what this surprise button is. The code looks like this: indirect case surprise fill. And I'm passing one of the fills as a surprise that I just pass it randomly. So that was fun. It was just an excuse to learn about indirect. Associated values can be used in a switch statement, the enum bread and butter. So we can make use of them there. They can be used also in combination with the where keyword, like as a filter, for more specific pattern matching. Or they can be omitted entirely if we need. Then there's if caselet and guard caselet, which I think they're extremely useful. I barely used them before I did this project. I really didn't understand them at all. I feel much more comfortable with them now, and I'm curious, I might disappoint some people by saying this. They're absolute fire. Like, I am totally on board with if caselet, guard caselet. So even with associated values, enums can conform to the kind of common protocols that are a necessity for SwiftUI, like case iterable, identifiable, hashable, equatable, comparable. And it takes very little work. So you can see there's a couple custom implementations there. And we can pack enums with a lot of great stuff. We can put nested structures in there. We can put custom initializers, functions, mutating functions, static properties, computed properties. That's a lot of gifts right out of the box that we get from Swift, and that Enums, they can handle it. There's one really important piece missing, and maybe you know what this is. Enums can't contain stored properties. And if they can't contain stored properties, then they can't hold state. I did know this going into this project. It was part of why I wanted to do it, to find out what are the other boundaries and how I can work around this. And I think I did that. Compared to structs and classes, they keep up pretty good, though. You can see that there. Are they right for every situation? Absolutely not. But they can do a lot. And in their very essence, as a value type, representative of one state at a time, out of a finite list of possibilities, they are inherently useful for a very important aspect of programming: representing state. So how can we use enums to represent state? Let's start with an example of representing a collection. So in my project, my mix is made up of a set of tracks. So you see here, class mix, publish var, tracks. And I don't think there's anything wrong with doing something like this. I've used this in the past. The view body might look something like this. If the tracks property is empty, we're going to show this add some tracks to your mix view. Otherwise, we're going to show the playback controls and the list of tracks. This works, but what happens if there are more than two scenarios? What happens if the binary of whether or not the set of tracks is empty isn't the only possibility that you want to work with? And this brings up a cool question related to representing state. How can we use enums to increase coherence in our code? Consider how isEmpty, a Boolean, is a binary, and it increases the coherence of 0 and 1 to true and false. It's kind of like a glow up on the 0 and 1. And we can use enums to take this even further. So even with two cases, it could be advantageous to swap the Boolean out for a two-cased enum. The benefits? Not only can cases be added later, switch statements protect us from overlooking those scenarios, making sure we account for it in the code. And the code can also become more readable. With Booleans, sometimes the narrative of the code just doesn't scan. It takes a little extra work, it's confusing, but with the power of naming cases in enums, we can improve that narrative and make the code more readable. So I experimented with this for representing a collection. Here's an alternative to the class, an enum mix with an empty case and a case that contains a set of tracks. Here in the getter, we retrieve the tracks if the mix has any, and then I set them based on the new value of those tracks. Note that the isEmpty property is still useful in the enum. But over in the view, now I'm switching on the mix enum. So I'm going to be cashing in on all three benefits of the two-cased enum here instead. So I really enjoyed this little experiment. So I want to discuss a slightly more robust example of increasing coherence from my app, PocketPerc, and this has to do with repeat mode. The app has conventional repeat options, don't repeat, repeat once, and loop forever untold otherwise. And the music is powered by the AV Foundation framework, which I just mentioned because this audio player object, that's where I'm getting this number of loops property. It's an AV audio player. And the number of loops property is an integer, and so I can pass it 0 for don't loop, 1 for loop once, or some negative integer for loop forever. That's coherent enough to understand, but the UI side is not great. If you were reading the code, you might figure out what this means. This with the system name, if the value is 1, I want the little 1, the little repeat. Otherwise, just the repeat sign, and then with the fill, the last line, put a background, if we're repeating it all. This can be more coherent, though, and it kind of speaks for itself. Repeat mode, enum, case none, case once, and case forever. And you might have guessed this is what it could look like, and it absolutely could. But we know on a deeper level that we're thinking about this in terms of integers. We're essentially saying that none represents a repeat of 0 times, while once represents a repeat of 1 time. And look at that similarity. So instead of all 3 cases, I opted for a case times with a total number of repeats and a case forever. The really cool thing that I'm completely obsessed with is convenience cases. So we can leverage that 1 times case to get us these 2 convenience cases, the dot none and the dot once. And outside the enum, that's how they work. We can call them just like the dot forever case. But inside, we're just making this a little cleaned up. Love it. There's a manual conformance to case iterable with that all cases property. So that's behind the button. And there's the system name, and then there's the value. So that's what the AV audio player is going to need based on what the repeat mode is. Then I wrote this little custom initializer where I pass in that number of loops property so we know what the repeat mode is to start with. And here's the implementation. So this property repeat mode, here we use that initializer and get what the current repeat mode is, and then set it based on the new repeat mode's value and pass that into the player.number of loops property. The view goes from that to this. It's definitely an improvement. I mean, there's no more strings, and it's easy to understand in the fill line that we want a clear background if there's no repeat desired. So that works quite well. And here's the call site to turn it into a button. The step forward function is the only part that I haven't shown you, but I just want to take a second to show you because I'm quite proud of this and I've really enjoyed doing it. So these views, the repeat mode toggle button, the carousel picker in the quick select view, and the forward and backward button in the browse view, they all have something in common. They're all powered by enums that move the state either forward or backward. So where do these options come from? How do we know where we're going? A conformance to case iterable. And this extension allows conforming types to either step forward, step backward, or return an instance of whatever is a header behind it in the all cases array, using these next index and previous index properties. And all it takes to conform are those two generic type constraints at the top. The enum has to be equatable, and we have to be able to index the all cases with integers, which we can do. So that's no problem. And yeah, I found one of these on Stack Overflow, and I just thought it'd be nice if any case iterable type could use them. So I really enjoyed getting to use them in these very different parts of the app. OK. Another aspect to state management is streamlining multiple states, or put differently, mitigating single source of truth violations. So let's start with the stop button. If no audio is playing or paused, I want the button to be disabled. What is there to stop when nothing has happened? But there's a red flag here. It's not how extra ugly this player is because I didn't unwrap it. But if you know what you're looking for, luckily the red flag is pretty easy to spot. And it's multiple conditional checks. So having multiple properties describing the state of things can mean multiple states. And I want to break this down a bit, first by simplifying the disabled modifier. So if the player is not playing, which by the way, this is playing property, it's just get only. So as you call player.play, player.pause, player.stop, the is playing property will be adjusted accordingly for you. So if the player is not playing and the current time is 0, then I want the button disabled, otherwise enable it. So consider this sequence of events. There are the properties. The default state is playing as false. Nothing's playing, the current time is 0, so the button is disabled. The user taps the play button. Is playing is flipped to true, that's good. Current time is whatever time as the audio plays, and the disabled button is enabled. We can go ahead and stop the audio. Then the stop button is tapped. Is playing is set to false. That's good, but the button's not disabled. And the reason is because the current time property is whatever the time is. So it's not really stopped, it's really paused. And that's a conflict. So there are really two problems. Number one, the current time is not automatically set to 0 by the AV audio player, and it would be amazing if it was, but it's not. So that's the first problem. The second problem is, even if it did set current time to 0 for me, I still have multiple conditional checks in this modifier, which can indicate that an enum would be a good choice to represent the state, although I'm sure there are exceptions to that. And because I can't rewrite the AV audio player, I cannot rewrite it to automatically set the current time to 0 and streamline its state, I can use an enum as a layer between the player and my views to do this. So that's what I did. So I used this enum called playback state, which is either playing or paused at a particular time of type double, or it's stopped if the value is 0. So another use of convenience case. I also added a mutating toggle function that the play pause button uses to go back and forth. And here's another custom initializer, similar to the last one. I pass in the player so that I can use its current time and whether or not it's playing to determine what is the playback state. And here's the implementation. So we're calling that in the getter. And then in the setter, I'm calling this update player from new value function. And that looks like this. So there you can see if the playback state is stopped, that's where I'm calling player.stop and player.current_time equals 0. Benefit number 1, the UI call is much better. It's much easier to read and write. That's pretty clear. Benefit number 2, there's one source of truth, which ultimately has always been the AV audio player. But now it has this bit of a bow around it to fix what I feel is a little murky about it. And a bonus benefit is that the views have no idea that an optional AV audio player even exists, which is great. It was way worse before, so that's been much better. And there's actually one more bonus benefit to this in the app. So on the left, you can see the optional AV audio player that I've been talking about, and I use that for the browse view. But on the right, I use AV audio player nodes instead, and I'm not going to get into the reasons why, but they are different, and they have different properties. Naturally, both views have playback controls to control their respective players, so they do need a playback state. The only issue, the AV audio player's current time is a double, but the AV audio player node, that one works with AV audio frame position, which is a kind of integer. Fortunately, they both conform to numeric, so I ended up making one generic playback state and just had fun experimenting with generics and enums working together. Okay, that's my dog. I gotta get some water. That was a lot of code. All right, it's just nice to see her little face as well. So that brings me to my last topic. Like I said, I always liked enums. One feature left me absolutely gobsmacked when I learned about it, so it had to go in the talk, and I have to shout out Stuart Lynch for being the person who hipped me to this. So I'll set this up a little bit. So it has to do with a view like this, track view, and it's comprised of some smaller controller views, the mute button, the solo button, the pan knob, and the volume slider. And I've always craved better and better ways to group views together, the kind of views that just go together. I don't know why putting them in the same file or the same folder was not enough for me. And in some cases, this would be a great choice. It's a caseless enum used as a namespace to hold those things. And we can certainly put other static properties of other types in there, but we can do it with views. So it is useful for keeping those things together. It works particularly well when the views have no dependencies. But when they do, I don't think it works. I haven't found a way to make that work. So when they do, like this, each of those views changes some property, so they have a binding to that property. And how would this be useful? Well, this is the nugget that started it all. Enums that conform to view! Yes! Come on. Hopefully some of you have tried it, and hopefully it makes you as happy as it makes me. The only requirement of the conformance to view is a body property, which enums can have because it's just a computed property. So I just want to show you that body. The first two are buttons, so you get it. But the pan and the volume are a little more fun because they just look like a regular view body. And even though it looks like I only have a constant to work with that let bound value, you can see I'm accessing the wrapped value. So we kind of still have that enum syntax, but we're still getting to use the binding, and it still updates the view, which is pretty cool. And same thing with the slider. Normally we'd have a $sign to bind it, but we don't need it because that is the value. So we can just pass that in. Value is value. At the call site, it's an H stack with a mute button, solo button, pan, volume, and you can tell what they are. They're all track controls. It just makes me really happy. I'm so obsessed with it. I don't know what it is about enums conforming to views that just gets me so excited, but it does. I love the way that they go from an abstract representation of a view to a literal view. An enum, they're views, they're not structs. It's very cool. So if there's one clunky thing, it's this. Even if all cases have the same associated value, you have to pull them out individually in the switch. And it is a little bit tedious. That's it, though. That's the only thing I don't like about it, and it's very marginal. I just thought, I was in this to find the ceiling, and I didn't want to just only share the lightest lifts of what I found, so I thought it was, important to just mention that. And I thought by the end of this project, I'd have a bunch of code that I would never put into a real app, an app that I would ship. It turns out, I think I would use a lot of it. I'm still exploring it, and I look forward to, hearing other people's thoughts and ideas about it. But I look forward to overusing enums a lot more. It was really fun. So why enums? They're simple, but they're robust in capability. They're static, but I find them really exciting. To me, they are the shit, and it's been a treat to share this with you all. We've arrived at the mix part of the program, so what I need is for people to call out instruments. I'm going to take about 8, and then we're going to do the mix, and that's it. So,
Bongos.
Yeah.
Horn section.
Yeah, okay.
Electric bass.
Yeah.
Flute. Walk cowbell.
Yeah, what kind of drums? Okay, and 1, 2, 3, 4, 5.
We need your vibro slab.
Yeah, we do. Yeah, we do. All right, cool. That's it. Okay, here we go. So, yes, and cool. Okay, so we have bongos. Let's get this going. Ooh. Nope. 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 That's not what we want. That's not it. No. Yeah, thanks. Oh, boy. I'm ready.
You ready? Okay.
Yep. Okay.
There wasn't really anything new. I just,
Only problem is it's going to come through here. Can you hear this at all? This was not the dream, okay? All right, let's see. What else we had? We had cowbell. There it is. Man.
This is awesome. We've got like a live band. We could use this for the interval music. We got licensed music, James. We can get it on YouTube. Oh. I thought it was on the screen. I wondered how you was.